Last thing that is going to be contained in this section has to do with when two chords intersect one another. And the relationship that exists is the segments that are cut off by these intersecting chords are going to be cut off so their products are equal. What that means is if you take segment AC, chord AC, the segments cut off on that chord, A, B, and BC, are going to have the same product as the segments of the chord cut off on DE. So it'll be segment DB and BE. And so that product will be the same on any chords that intersect one another. And there'll be, again, kind of levels of difficulty as far as what I'll have you guys work with on these. Regarding the simple types of problems, it would be something where I just simply give you some of the values. So if I told you that AB was 6, BC was 4, DB is 8, and you want to solve for BE, the way that you would do that is you'd simply set up your general equation or relationship. The product of the segments cut off by intersecting chords will be equal, and then just plug in the values. So AB was 6, BC was 4, DB was 8, BE was X. And so if you simplify, 8's cancel, 4 goes into 8 twice, 2 goes into 6 3 times. So you get 3 is equal to X for your solution. Okay, so that would be the easy application of this relationship. The more challenging one, and the one more likely that you guys will see, would look more similar to this. Hey, if I gave you the following pieces of information. So if I told you that BD was 9, DE was 19, and let's say AC was 23, and I asked you to find AB and BC. And just take a moment or two and see if you can work with this information and take it anywhere closer to finding A, B, and BC. This, if you label what you have, DB is 9. If DE is 19, what does that mean BE has to be? 10 is left for that, right? If the whole thing, the sum of the parts is equal to the whole. And then if AC, this whole thing, is 23, you can set up your relationship. You know that AB and BC's product has to equal DB and BE's product. Well, you know that DB and BE, but what you don't know is the other segments. If that's the case, what you need to do is you need to assign one of them an unknown. And in mathematics, you do that by just giving it a variable. We'll call it X. It doesn't matter whether X is on AB or BC. And now using segment addition, if we want to find the other part, so we have two parts in a whole, the other part is equal to what? The whole minus the other part, or 23 minus X. So if you think of it in those terms, what you can now do is express AB as X, BC is 23 minus X. So we have one equation all in terms of one single unknown. So we can go through and solve. Now, two ways to solve if you have your calculators. You simply type in the word solve, parentheses, type everything in exactly as it appears, comma X, close the parentheses, and that will solve for X for you. If you're doing this by hand, you simply need to distribute through. So you get 23x minus x squared is equal to 90. And so now you're dealing with a quadratic equation. When you solve a quadratic equation, you move all the terms to one side, write it in standard form. So let's write it so the leading coefficient is positive. So we're going to add an x squared to both sides. Subtract a 23x from both sides. That's moving all the terms to the right. The 90 will stay on the right, and the left means we removed everything, leaving just a 0. And now what we can do is we can look to factor. The two factors of positive 90, whose sum is negative 23, is negative 18 and negative 5. And so when you use the zero product rule and you solve for this, you get two possibilities for your x. X is either 18 or x is 5. Doesn't matter which is which. Can you tell which is which? Right? Assuming the diagram's to scale, you would say that x is 18, or that AB is 18 and BC is 5. But if it's not necessarily to scale, it doesn't matter. It can work either way. The only other way you can specifically tell which value goes to which dimension is if it gave you something like this, if AB was greater than BC. If that was part of the givens, now you'd know that AB is 18 and BC is 5.